Suppose I have two random variables, big X and big Y. I have three particular values for small x and three particular values for small y. Let's say I want to find this. What on average you will see regarding x if given that y is larger than y2. Do not work on this table. You should make a new table. I will combine the thing below into a big table. So I will have this. This is now one box. This is now another box. And this is now another box. So that means what? You combine table. Remember the football situation, not lose means draw or win. So I combine table. So if I have more than two boxes, I can always do this. But if I only have two boxes, then there's no such thing by combining table. Then you can work on it directly. But if you have more than two columns or more than two rows, let's say this 6 box or 9 box, if you try to work on this table directly, you can, but it will be very tedious. So don't always simplify the table, make your life easier. Okay, now I'm going to talk about this ultimate example. If you understand everything, how to calculate this 18 thing, you are safe. What's the sample space? The sample space is x is 0 and 1. Y is also 0 and 1. What are all the possible sample space? It will be the Cartesian product of 0, 1 and 0, 1. So that means 0, 0, 0, 1, 1, 0, 1, 1. What are these? 0.2, 0.4, 0.4, 0. They are joint probability. What does this 0.2 mean? It means the chance seeing both x, y 0, 0.2. The chance seeing both x, y is 1 is 0. The chance seeing one of them is 1 and other one is 0 is the same, 0.4. Okay, so this is a meaning. Then what about the chance seeing y is 1? The chance seeing y is 1 means I don't care what is x. So I just care about this column, right? So this number means y1, x0. This number means y1, x1. But I don't care about x, so I'll just sum these two numbers. So the chance seeing y is 1 is 0.4. What about the chance seeing x is 1? The chance seeing x is 1 means I don't care about y. So I will sum these two numbers. That means also 0.4. If the chance seeing y is 1 is 0.4, what's the chance of seeing other cases? 1 minus 0.4. That means 0.6. Correct, because these two numbers add together is 0.6, which correspond to not y1, right? Y not equal to 1. Same, if the chance seeing x is 1 is 0.4, I don't care about y. What's the chance otherwise? 0.6, which is these two numbers add together, right? What about the chance seeing x, y have different value? That means not 0, 0, not 1, 1. Then it's these two boxes. Add together 0.8. Okay? What about the chance that x and y are the same? That means x0, y0 or x1, y1. It will be these two boxes add together. That means 0.2. Okay? Then this is the first level. That means you first need to know all the chance. Once you know the chance, then you can talk about expected value, because expected value basically is just the value multiplied probability. And once you know the probability and the expected value, then we can go to variance. And once we have variance for one variable, we can go to variance for two variables. And once you have all this, then you mix up condition and other thing, then you have other thing. Let's talk about one by one. What is this? Chance of seeing x is 0. That means I don't care about y. So I push this table. I squeeze it, so this becomes 0.6. This becomes 0.4. So it's same as I don't care about this direction. I squeeze this table. Okay? Then this is 0.6. This is 0.4. Then of course it's 0.6. This exactly what's that? 0.2 plus 0.4. It means what? It means this box plus this box. What is this box? Both x, y is 0. Both x, y is 0. x0, y1. x0, y1. So that's the mean. What the chance? Y is 1. Y is 1, I don't care about x. I squeeze it on top. Then I add these two up and add these two up. So that means I just consider these two numbers. That will be 0.4. Right? Yes, 0.4. What does it mean? x0, y1, that means this box. x1, y1, that means this box. These two boxes add together. Actually what I said, squeeze the table. So that's 0.4. So that's how you understand 1, 2, all the p. Okay? Then what about ex? Ex is what? No y. I don't care about y. So again, first I squeeze the table. Then if I squeeze the table, I will get a new table. This kind of problem, please always write down a new table. Don't work on this directly. Very high chance you make mistake. Okay? So if I squeeze this table, this is on ex, right? Only on x, so I have only x. Okay? And I have only two numbers. What number? I add these two numbers, so 0.6, this number 0.4. What will be ex? This number multiply this number, add this number, multiply this number. Why? Because ex is what? xpx summation. The product between the x and the corresponding probability product, and then sum over all the x in the sample space. Okay, so that's it. So that's the idea. So 0 times 0.6 is 0, so it will be 0.4. And this is 0.4. Why? Because 0 is this 0. This thing is this 0.6. This 1 is this 1. This thing is the probability I see x equal 1 ignoring y. So therefore, is this expression. 0 times anything is 0, so I don't care. 1 times 0.4 is 0.4, so I get this. Similarly, you can get EY by what? You squeeze the table along the x direction, you don't care about x, so you get another table, okay, and then you calculate the same thing. Then what about EXY? Okay, now we have this funny EXY thing. XY is a new random variable, I call it Z. What's the random variable here? It's x multiply y. It's not x plus y. It's not x comma y. Okay, it's x times y. So my variable here, it will be the multiplication. Let me remind you, E random variable x is summation of all the small x, p small x, right? I can replace this by whatever symbol I want, right? So I replace it by whatever symbol I want, right? I draw a house here, then I draw a house here, then I draw a house here. That means what? This is the house. XY is the house. I can change this from multiplication to what? I can even ask you, for example, what about this? Then you change this to e power y. This means what? This means due to some reason, I want the e to the power y. But this expression have nothing to do with the occurrence probability. Then I just keep the same number here, and then this number, this whole thing will change. Okay, that's the meaning. So how do I calculate expected value of product? Then I have how many cases? 4 cases, 0, 0, 0, 1, 1, 0, and 1, 1. So for EX, I have 0, 0, 0, 1, 1, 0, and 1, 1. What is this P? This P is corresponding to the case I have 0, 0. What is this P? This P corresponds to the case I have 0, 1. What is this P? 1, 0 corresponds to the outcome I have 1, 0. What is this P? The correspondence of 1, 1. So I get 0. Okay, see funny. This problem, if I want to find out on average, I have X and Y, and I want their product. On average, I get 0. And then what? Well, let's do this one. It will be what? The chance X is 0, Y is 0, and then the probability that X is 0, Y is 0. Okay, very quickly we start because this is undefined, so no. But let's say if Y is not 0, 1, but 1, 2, then I can still put the value here. Because 0 to the power 0 is undefined, so we cannot do that, but you got the idea, right? That means I can do any fxy here, as long as fxy is legal. Same, if I have this funny table, that means I cannot ask what is the expected value x divided by y, because I will have 0 divided by 0. So I cannot do that. But can I do x plus y? I can. Can I do minus? I can. Can I do multiplication? I can. I just cannot do power or a division. Okay? Covariance. Let's recap what's variance. V of a thing, let me now call it Z, okay, is what? Is a funny expected value. What? The Z minus the average value, and then what? Repeat itself 2 times. So this is variance of Z. What's the variance of xy? Now I have the same thing. This is x, this is x, this is y, this is y. So I have the same expression, okay? But now one particular bracket is on x, while another particular bracket is on y. So I just do the same thing. Once I have this expression, this is just a funny f. Then I do the thing again. I have a houses here, then I put the houses here. This houses is xy in this case. Variance can be expressed as what? It's also what? Ez squared minus Ez whole thing squared. So you either calculate this and calculate these two, and then you subtract them, or you use the definition, both are the same. In this slide, I use the second way, compute EXY, and then EX minus EY. Why I'm doing that? Because previously I have EXY. EXY is 0. Okay? In the 4, EXY is 0. So this first term is 0. So 0. Then I need EX, EY. I also have found EX and EY previously. EX is 0.4, EY is also 0.4. So therefore, the whole thing will be negative. Okay, here's a mistake. This is subtraction, so this should be subtraction. So negative 0.16. Okay? And this is not 0, right? Not 0, that means what? They are not independent. Okay? And this has a negative covariance. That means what? That means if x is larger than the average x, then very likely y smaller than average y. Remember those funny figures? That's actually the meaning. Okay? Then what's next? Vx, Vy here, I do the long expression. So what's the Vx? Vx is, I don't care about y, so first I collapse the table into only on x. Then I only have 2 cases. X is 0, x is 1, and with their corresponding probability 0.6 and 0.4. First, I need to find Ex. I have previously computed is 0.4, then I can now do this long formula. It will be x minus Ex whole thing squared times the probability, and do the same thing on the other part. Then it gives me 0.24. Because this table is symmetric, so therefore y is also the same. Then what about correlation? Well, correlation is covariance divided by square root of the variance. Therefore, you just divide it, it's about 0.66. Okay, 1 to 8 are just unconditional stuff. Now, the following are all conditional stuff. What's the condition? Join divided by marginal. So, for example, I have this. The probability of seeing x is 0 given that y is 0. This is condition x given y. It will be marginal on the bottom and the join on top. X, y on top with a comma, and then in bottom. How to remember it? You can remember this bar and this bar. So this thing is after the bar. So here, this thing is below the bar. You can somehow remember it like this. Okay, then I have this P, both xy is 0, which is this box, 0.2, divided by probability y is 0. Ignore x. Previously, we have found that it's 0.6. So it will be 1/3. That means what? Let's say this is tossing coin, and I toss 2 coins. If the second coin is y is 0, what's the chance the first coin is 0? Then it will be about 1/3. Okay? Well, this is not a good story because usually coin is independent, but this is not independent. This is dependent. That means magically the second coin will affect the first coin. What's next? Expected value under conditional probability. So EZ is what? Now I have an FZ, okay? If I have some F here, it will be what? All the summation of what? All the small f on the Z, you can apply. Multiply the corresponding probability Z here, okay? But now if I have a bar here, this is related to conditional probability, so I will put a bar here, right? Something, let's say I call it theta, okay? It's the same formula. So what is this thing? This is saying that what's on average I should see on x given that y is 0. This is different from EX. EX is saying that I don't know what is y. On average, what I see on x. This is what? This is, I assume I know y is 0. What is the average value of x? They are different, okay? You can see this one is 0.66, this one is 0.4, it's not the same thing. So how do you calculate it? It's the same thing. So now this f have no f because this is just x. That means this is just z. The probability is the probability, but now it is becoming what? Conditional probability. So now this part have a bar. Okay, and then you do the same thing here. 0.66. That means what? That means I can also ask you a question like this. Expected value of x squared given that y is 0. Then now I have a f. And this f is square. Right? And now I told you last time, this f can be any f. This f can be this kind of thing. I can call this thing my f, right? Which is another random variable with a lot of messy stuff. You can do that. And therefore you can keep going on forever. And therefore it's crazy. So therefore this kind of thing won't appear. So usually no more crazy stuff. Then if you know how to calculate this one, then you know everything in the below. It just repeat everything here but go to variance. I'm not going to do the following. That is covariance xy given x is 1, y is 2. No. That's too much. Or I put a square root here, put a square. No. It will be just this. So that's the idea. How to do so? This one is given y is 0. So we change the marginal. We change the joint to conditional. This one is given y is 1. So we change all the joint to this conditional. That means you need to find this probability. What is this probability? Px0 y1, comma, divided by py1. Okay? And once you have this, you can define this thing as a random variable. Then what is this? Y have two cases, right? So you have a split function like this. It will be on average this value, given that y is 0, y is 1. Then you have to find the probability of y is 0, which is 0.6, and the probability y is 1, 0.4. Okay, something like this. So you have this kind of thing. So that means these two things give you a probability. This expression here is a what? It's a number, right? This number is a number. So that means what? If I have condition x given y, I see this as another random variable, then this is another random variable, I call it z. Then I can keep going on, ask you what's the variance of this, what's the expected value of this, and then I can keep going on, say, what's the expected value of z given that x is 0, and don't worry, I'm not going to go too deep. Okay, so this is the idea. What is this? This is EZ. That means you can think of, what is this? This is E, this thing on top of this, so you have double E. So you can think of this as double E. And then you can go double V, double E, and then EV, like exactly what I said previously, like this. Not going to go over 2 level, at most 2 level. So that's the idea. So, very important, know how to calculate this. Most likely I will stop at here. And most likely I'm not going to here, but there's a chance that this will appear. And of course I'm not going to tell you what's the chance, okay? So study this. So this will be the hardest part in statistics, and that's it.